blocks of graph?
This is 4.3. I'm on page 174. This is example 4. So the problem's already up there. What we're looking to do is we're trying to find the equation for a line tangent to this graph. So an equation to a line that's tangent to that graph, which means that when we're done, we're going to have this. So what we're going to need is we're going to need the x value, or I'm sorry, the x1 value. We're going to need the y1 value, and we're going to need the slope. Well, we've already got the x value as -1. So what we need to do is we need to find this value here and the slope. So that's the direction that we're going to head with that. We don't need to find the derivative of anything in order to find that y value. We just need to plug x in here because the arc cotangent of x, or -1, is going to give us our y value. So that's what we're going to do first of all. Find the y value by plugging -1 in for x. But the problem is, like I said earlier, you don't have an arc cotangent on your calculator. In fact, we don't have any formulas or anything for arc cotangent. So what we're going to do is we're going to change the cotangent into one of the 3 identities that we do have on our calculator, or that we are able to figure out. So we need to change cotangent into either tangent, sine, or cosine. And that's where top of page 174, that conversion identity comes in, because it says that the cotangent of -1 x equals pi over 2 minus the arctan, which arctan is good, of x. So we're going to use that identity from the top of page 174 in order to first of all find what our y value is. So what we're going to do is, instead of an x here, we're going to put a 1 in. So we've got x over 2 minus the tangent of -1 of -1. So all I did was took my -1 that my x represents and stuck it in there. Okay, so if we have a graph, which I'm going to have to move some stuff out of the way here. Let's see if we can get a graph up here. Tangent of -1. That is going to be an angle that our opposite over adjacent gives us -1. So that will happen in either the second quadrant or the fourth quadrant. Since we need a -1, we need either the opposite or the adjacent to be negative. So in this case, our adjacent is positive, our opposite is negative. In the second quadrant, our adjacent is negative and our opposite is positive. Do I sound like I'm more on top of it now? Okay. I also know that any fraction, opposite over adjacent, in order to get a 1 value, the top and the bottom, the numerator and denominator, have to be the same number. And if that's true, then this angle has to be a 45-degree angle, because a 45-degree angle has its opposite and adjacent sides equal to 1 when you put them over each other, or they're the same length. So now I just have to figure out at what point is my tangent negative, which quadrant is it's negative. So we've got all students take calculus. Okay. So what I'm going to do here is figure out where my tangent is going to be negative and where is it going to be negative. In 2 and 4. So it can be a negative here and it can be a negative there. Okay, so something that's very important here. It doesn't matter what quadrant we're in. The only reason I have the quadrants up here is just to show you that drawing a triangle, you know, how I'm going to get that -1. That's all I care about. It doesn't matter which quadrant we're talking about, because all I care about is that the arctan of -1 gives me a 45-degree angle. That's all I care about. Okay? So, and because it's negative, our 45-degree angle is going to be a negative 45-degree angle. So, what is 45 degrees? Let's get rid of some of this. What is 45 degrees in radians?
5/4.
Okay. So I know this whole thing here is pi over 4. Okay? That's all I was trying to figure out there. And actually it's negative pi over 4. Okay? So at this point I have pi over 2 minus pi over 4, and that is my cotangent, or my arc cotangent of x. So what is pi over 2 minus negative pi over 4? 3 pi over 4. What is that value? Why did I find that value? Because I know that the quadrant of, or I'm sorry, the arctan of x is equal to what? Y, and equal to that. So therefore, this is equal to y. So that's my y value. So now I have my x value and my y value. So there's my x and y. Okay, so as far as going back to my point slope form of the equation that I had up here, I can plug in a y for my x value and a y, or in a -1 for my x value and a 3 pi over 4 for my y value. Now all I have to do is find the slope.
So,
So
the tangent, the -1 times x, was that just because you figured out there was a 45-degree angle, that's how you solved that thing?
yes,
Okay.
yes. All right, so let's see if I can erase a bunch of my mess here. So this here is important because that's what you're going to plug into your final equation. Let me write up there. So to find the derivative, or I'm sorry, to find the slope, I have to have the derivative, right? I have to have the derivative of my equation in order to be able to get the slope. Okay, remember doing that? The derivative gives you the equation for any slope on the graph, and then we'll plug in our -1, and that will give us the slope of that equation at that point, -1. So what we're going to do is look back at page 172, and it tells me what the derivative of the arctan is. What is the derivative of the arctan? Middle of the page. Right above, the derivative is defined for all real numbers.
1/1.
Okay, so that is the derivative of the arctan. So what I'm going to do is I'm just going to plug -1 in there, and I'm going to get a value, and that value then will end up being my slope.
So you're finding the derivative of y, find the slope?
Yes.
Okay.
But I don't even have to actually find the derivative, because if you look on page 172, right here is the derivative of that tangent. So I don't even have to find it. I just turn back to that page, stick a -1 in there for squared, and I end up with a slope of negative 1/2. So
How did you get a negative?
1/2.
Wouldn't it just be 1/2?
Yeah.
Yeah.
Or
oh, I'm sorry. There is a negative out there.
That's the derivative of cotangent or cotangent x.
That is the derivative.
It doesn't have
It doesn't have the negative
Okay.
sign on it.
Explanation goes better. Okay, so let's make some room here and some room here. So the question has been raised, where does this negative sign come from? Well, what we're doing is, in order to find the equation of the line tangent to the graph here, we're going to take the derivative of that, and that will give us the equation of the line to that graph. Then after we do that, we'll plug in -1, and that will give us the slope of the line at that point. So to find the derivative of our original equation right there, first of all, we changed our original equation. We didn't do the derivative or anything, but we just changed it to pi over 2 minus the arctan of x. So, tangent of -1, that is not a good one,
Good one.
of x. Okay, so now what I need to do is find the derivative of this entire thing. So when I find the derivative of that whole thing, derivative of pi over 2, since pi is actually a number, the pi over 2 is going to be 0. The arctangent, or the derivative of the arctangent of x, if you look on page 172, middle of the page, it says that it's 1 over 1, is it plus x squared?
Yes.
Plus x squared. This negative here is still there, so it's going to go in front. Okay, so at this point, this here is the equation of any line tangent to this equation right here, our original equation. So now if we plug in -1 from up here in for x, we will get the slope at that point, which gives me 1/2 with that negative on it. So now we have the slope. So now that's as far as I need to go. I've got everything I need to make life grand. So I can rewrite this here as an equation. Y minus what? 3 pi over 4 equals slope times x minus. Okay, so that gives me an equation there of my tangent line at the point x equals -1.